So now we come to weak acids and what makes a weak acid. What kind of substance would behave as a weak acid? So what kind of substance make a weak acid? Well, if we think about what kind of substance made a strong acid, that was a stabilized anion, that negative charge being stabilized by electronegative elements on that atom or group of atoms, and or a weak bond due to a long bond length. So we saw this in HCl. That was a weak bond, and so it broke more. Now, what if we had these effects, sort of strong, long bonds and high electronegative atoms, but not to such an extreme effect as you have in HCl, HNO3, or H2SO4? Then you'd have a weak acid. So let's look at some examples. If we have, there's water, H2O. If we have H2S, then the bond length, the SH bond length, is longer than H2O because it's the next row down, and therefore it's a weaker bond, and therefore H2S would behave as a weak acid. What we're thinking about in terms of electronegativity is the stability of the A- ion formed relative to the OH- ion. So if we go across period 2 and look at the hydrides, there's CH4, NH3, H2O, and FH. The electronegativity increases as you go across that period because you've got more nuclear charge. And what that means is for the atoms prior to oxygen, the carbon and nitrogen are less electronegative than oxygen is, so therefore they're going to be able to stabilize a negative charge less than an oxygen atom will. So therefore these reactions are absurd. They would never happen. Whereas if we go to an atom which is more electronegative than oxygen, i.e. fluorine, then this will occur more than in water because that fluorine is more electronegative. Let's look at a strong acid, H2SO4. We know that breaks apart 100% of the time, and the anion is HSO4-, which has got 4 oxygen atoms, which are electronegative. What if we have not 4 oxygen atoms, but only 3? That'll be slightly less stabilized, and therefore this dissociation, breaking apart to ions, will occur somewhat less than for the H2SO4, and this is indeed the case. So H2SO3 is a weak acid. And an organic example here, if we look at ethanol, then if this OH bond was to break to form an H plus and an O minus, that O minus is no more stabilized than in OH minus because this carbon has a similar electronegativity to hydrogen. So therefore this reaction will occur as much as water, which is a negligible amount, or at least it will be neutral, have the same pH as water. Whereas if we replace some of these hydrogens with an oxygen atom, then that means that if we were to get rid of that H and form H plus and have an O minus, that will now be stabilized across 2 electronegative elements, and so will be more stabilized. And so this is ethanoic acid, which is a weak acid. So just to summarize, the kind of substance which makes a weak acid is the same as the kind of substance that makes a strong acid, i.e. stabilized negative charge due to electronegative elements and long bonds, which are therefore weak bonds. Okay, so that's it for what makes a weak acid. Next we'll go on to how to calculate the pH of a weak acid.